All right, so today we're going to do area between curves, which is going to be a foundation for our unit. And the idea behind today is, how do you find, if I have a picture and I have two curves, and I do it with points just real quick to make sure you understand what I'm doing. Let's call this point 5 comma, I don't know, that looks about 5 comma 2 to me. And then I have some other curve here, whatever, and this is the point. That would be 5 comma 5. Well, obviously the area between the curve is this area in here, correct? And so it's like I want to add up all of these distances, if that makes sense. So if I could stack these things real close together and add up those distances, that would give me the area of that curve. Well, here's the deal. What's different in this unit is the first choice you're going to be making is if you're going to do dx or dy. We've always really integrated with dx, but we might choose to do dy in this unit. So you're going to get almost tired of me asking the same questions, but the good news is you can become very mechanical about this and go through these questions and get all of them right. So notice that when I fill that area, I am doing vertical lines. So I'm stacking. If I did the vertical lines, I'm doing like this. So think of this as being dx. So if I wanted to do dx, again, I'm going to think about these distances of these lines. Well, if I ask you this specific pink line, what is the distance of that? You would say, well, I would take, the 5 minus the 2, and it would be 3. So I would do the top curve minus the bottom curve. And even if it was below the x-axis, I would still do that same thing, top minus bottom. And so that's what I'm going to do when that's going to kind of be my first choice in finding area. We'll look at a different case after a while. So the first step is going to be to draw a picture. It says find the area of the region bounded by those two curves, well, really 4 curves, or two graphs and a couple lines there. So you have to draw a picture and figure out what bounded region they're even talking about. So in the graphs, it will obviously, and I'm going to do some with a calculator and some without. So the front side I'm going to do with, the back side I'm without a calculator, and the back side I'm going to do with a calculator. So the ones that you'll have to graph without a calculator certainly would be ones that you should be able to graph. X squared plus 2, you should be able to go, okay, that does something like this. That does here. And then what does y equals negative x look like? Well, y equals negative x, of course, looks like this. X equals 0. You'd be surprised how many people misgraph x equals 0. That is a vertical line right here. And then x equals 1. I like overemphasizing my areas because I hate when I do things small. It messes me up. So I kind of really overemphasize this one, but there we go. X equals 1. And so there we have it. So what area are we talking about? Hopefully you're with me. Again, the word bounded, friends, it means it's closed in. So your area, you can't find the area of, say, this up here because that would be unbounded. Notice that the bounded region that I'm talking about that's bounded by those 4 equations is this area in here. Now ask yourself, when I draw these vertical lines, do I have the same curve on top and on bottom? You go, yeah, I do. So the formula for area is going to be very simple. I'm going to go area equals, I'm going to sum up because we know that's what an integral is. And I'm going to go in this order. I first figure out if I'm going to do dx or dy? Well, if I draw vertical lines and I have the same curve on top and bottom, then I'm going to choose to do dx. And so I'm going to get my area right here. Now, the reason I do dx first is because it's very important for you to understand if you're doing dx, these are x values. That's why I put x1 and x2. So what are my bounds? Well, looking at my bounded region, what is the lowest x value of my bounded region? Well, that's right here, and of course that would be 0. What is the highest x value of my bounded region? And that is 1. And what am I going to integrate? Well, here's the deal. Remember on this example, I said, what is the distance of this line? And you said 5 minus 2, so you subtracted the y's. But the problem is, I can't say, oh, let's do y minus y, because I'm doing dx. They have to be in terms of x. So here is something that is true for this entire unit. Friends, if you are doing dx, your equations have to say y equals, because yes, I want to subtract the y's, but I have to have them in terms of x. So let me ask you, what is this top curve? Which one was that? Well, that was x squared plus 2. Top minus bottom. Now, what was the bottom curve? The bottom curve was negative x. Now, obviously, I know that you just say, can I just write plus x? And of course you can, because if you're about to integrate, you probably would do that. But I just want to make sure that you understand that I am following this equation. Top minus bottom. And yes, I would change that to a plus, an ugly plus. And if I had to solve this one, if this was on the non-calculator part, well, then I'm just ready to roll. I have 1/3 x cubed plus, I'm sorry, I'm going to go in order, so I'm going to integrate this x next. 1/2 x squared plus 2x. I need to evaluate that from 0 to 1. And so plugging in the 1, I have 1/3 plus 1/2 plus 2 minus, now I'm going to think about plugging in 0. The nice thing with this one is if I plug in 0, I actually get 0. So I don't have anything to subtract there. So all I have to do is add up those things. Common denominator, what is that? That would be 2, 6, and 3 6. So my answer is 2 and 5 6. You can either write it that way. Obviously, do I care if you write it as 17/6? Same thing. So my area is going to be that right there. And that's how you do the area between two curves. Now, obviously, every problem is different. There are some things I might have to do differently. So let's look at example 2. And again, we're going to do this one without a calculator, so I have to think of what I have to do to get all that I need to do. Find the area of the region bounded by those two curves. Well, let me think of those two curves. Well, y equals x squared, that's a pretty easy one. I don't have to think too hard about that guy, so I have him. This one, again, if it's non-calculator, I guess my brain would think, well, I mean, I know it's an x squared that's flipped over. It's probably pretty easy to factor an x out, or a negative x. You could do either one. And you would end up with a parabola that would have zeros here at 0 and also at 2. And you know it's going to be a down parabola because of the negative x squared. So it's going to look something like this. And so where is my bounded region? Again, I know it's hard to think about because you go, well, I kind of see two bounded regions. No, you don't. You only see one. And somebody looks at this region here and says, well, it's bounded. Y'all, even though when you're drawing the graphs, you can't look at the x and y axis as a bound unless they tell you. So although this region looks bounded because of this x-axis, the x-axis was not a equation that they said bounded by. So there's only one bounded region, and that's this region in here. And that's what I need to find the area of. So that is my bounded region. Again, my thought process is, I know I'm going to take the integral. My first decision is, am I going to do dx or am I going to do dy? Well, when I look at my bounded region and I draw those vertical lines, do I have the same top curve and the same bottom curve? Yeah. So I choose dx. And so if I choose dx, then I have to find then my bounds. I usually do my bounds next because I'd hate to, some people forget to do the bounds. So that's why the second I figure out dx or dy, I do my bounds. Now, if I said what is the lowest x value of my region, that one you can really tell from the graph. You'd say, well, that one's 0. What is my upper bound? What is the greatest x value? Well, I mean, unless you're drawn on graph paper, you're like, well, I mean, I don't know exactly what that is. So how do I find it? Again, this is non-calculator. How would I find that value? You'd say, well, I would set those two equations equal to each other. So I'm going to go ahead and do that over here. If I set my two equations equal, and I can bring everything to one side, I would have negative, I'm bringing to the left for some reason, negative 2x squared plus 2x is equal to 0. Let me pull out a negative 2x. And what would I be left with? An x minus 1. And so I get x equals 0 and x equals 1. So cool. That gave me the x value. It makes sense that I get 0. I kind of already knew that one, but it helped me get that top bound. So again, if your bounds aren't intuitive from the picture, then you're going to have to set your equations equal to solve. Now, how do I get the integrand? Well, every time to get the integrand, if I have vertical lines, I'm going to do top minus bottom every single time. So which one is my top curve? Well, my top curve was this one, wasn't it? I mean, look at your picture. It's the upside down parabola. So it's going to be 2x minus x squared minus the bottom curve. Well, the bottom curve was x squared. Now, obviously, before I actually start to integrate, I'd probably clean that up. So I'd have the integral from 0 to 1, 2x minus 2x squared dx. Don't forget to put your dx's. And then what do? I just start integrating. So if I integrate 2x, I get x squared. If I integrate this, I have 2/3 x to the third. I'm going to integrate that from, again, kind of nice, 0 to 1. So I'd have 1 squared minus 2/3. And again, I'm going to put minus 0. I don't want you to think it's always 0, because it's not always that way. So what is 1 minus 2/3? Well, that's pretty simple. My area is 1/3. So hopefully you're seeing it's kind of the same process. I just have to figure it out. Now let's go to the back and let's consider that these guys, you are on a calculator portion. So if they're in a calculator portion, well then I can do all sorts of things. So let's look at this one. Find the area of the region bounded by the curves, sine and cosine. Okay. X equals 0 and x equals pi over 2. So let's look at that one. I'm not saying you couldn't draw sine and cosine by yourself. I'll be honest, you should be able to draw those. But again, if I have a calculator, I'm probably going to use the calculator. So let's see what I'm going to do on the calculator. Well, first of all, I've always got to check my mode because I never know what it's going to be on. So it's good to go. So I'm going to put in sine and cosine, and I'm going to make note of which one I put where. You know, like on my paper, I would probably denote, okay, I put this into Y1 and this one into Y2. I could do it like that maybe, just so that I could have that in my head. Now I know I have on this is a really cool calculator that you can do colors. I understand that you guys don't have, you know, if you're using my calculator on the test, you won't have that. So I want to show you something that you can do. And I'm not sure if it'll do it on this one because of the colored, but if you arrow over to this thing and hit enter, yours is not going to have a color, but yours is going to be able to change this into different things. So you can make one of them thicker than the other. So if, not that you don't know what sine and cosine looks like, but depending on if it's graphs that you're like, which one is which? I don't know what these graphs look like. It's kind of nice to, again, you arrowed over to your line. Again, you don't have a color, and you can make the lines thicker, one thicker than the other. So let's see if I can do that. So hopefully it did that. Now I am going to, again, look at this graph. Notice it said x equals 0 and x equals pi over 2. So if I think about those graphs, I really, if I'm cutting it off at pi over 2, I really don't need to look beyond that because that's going to be a bound. So I'm going to set my window from 0 to pi over 2 because I don't want to confuse myself in looking at the graph in a ton of other places. Now, if you'd like, because it's not very, I could have made my y's a little bit smaller, so let me go ahead and do that. In my window, instead of making it -5 to 5, I know sine and cosines between 1 and 1, -1 and 1. So let me make that, I'm just going to change that to there. So there's sine coming. And again, yours on your screen is going to be thicker than the other. Hopefully you can see that. So again, what is the bounded region? Half the time people miss this question is because they find the area of the wrong region. Let's look again what it says the curves are. It says x equals 0. It says sine and cosine. I'll put this over here so I have room to write. Okay. So I have sine and cosine, x equals 0, and x equals pi over 2. So I'm going to just get it on my paper so that when you look back at this, you have it. Okay, so you have sine coming in, and I'll draw a little more of it than pi over 2 because I'm going to pi. I want to be very clear what the calculator zoomed in on. And then I have cosine. Cosine comes, again, this is actually pi. Cosine comes like so. Like so. Cosine does this and then comes like here. Now notice what I drew more on my paper than the calculator because remember this is pi over 2. So I also have x equals 0 and x equals pi over 2. So that's why, again, it's smart to set your bounds on your calculator because all this stuff over here is kind of confusing. So you're going to find the bounded region. I have 2 bounded regions. Do you see that? I'm now going to erase and have what the calculator has so you're not confused. Okay, this is what I have. Okay, and here's what my bounded region is. Again, don't look at the x-axis. It didn't say y equals 0. So I have bounded regions here and here. Right? Okay. Now, let's think about this. And I know you could get this on the calculator, and we'll do that in the next one, but I just want to make sure you understand. If it was on non-calculator, could you figure out where those two hit? Where does sine of x equal cosine of x? Where are sine and cosine the same at what x value, what radian measurement? And you're like, oh, pi over 4. So yes, that would be at pi over 4 where those would hit. Now, what do you notice about this bounded region? I'm going to move this guy down just a little bit. Sometimes with the area that they're talking about, you have to write it as two integrals, because even if it was a connected bounded region, sometimes your top curve and your bottom curve aren't the same. Do you see how I have a different top curve and bottom curve for the two regions? So I have to split the area into two integrals. So let me look at this first bounded region. That integral, again, it's going to be dx, because again, throughout that region, do I have the same top curve and bottom curve? Yes. Who's on top there? Well, again, if you've made one thick and one thin, you know which one is which. You know that one, this guy is cosine and the blue one is sine. So this one is going to be cosine minus sine. And I did not put my bounds. My bounds are 0 to pi over 4. And I'll be honest, it's probably smart to put a parentheses there. Again, the dx bookends it, but if you want to be very clear, if you happen to forget the dx, if you don't have parentheses, they don't know what you're integrating. So it would probably be a smart thing to get in the habit of putting a big parentheses around what you're integrating. I can't say that I do that every time, but it probably, if I were taking an AP test, I would. So, so I have that. Now the second curve, the second bounded region, is going to be from pi over 4 to pi over 2. Now, what curve is on top there? Well, what's on top there? That's sine is on top, and then cosine is on bottom. So I have this. So again, I have two different regions, and the top and bottom curves are different. Now, if I have this in the calculator, I'm not saying you don't know how to integrate these things, because frankly you do. I could technically do this by hand. But again, I want you to see that if you have a calculator, it probably is smart to use it. So what I want to do is I want to get my calculator to look just like my paper right here. Now this is why I made the note of which one is in Y1 and which one is in Y2. So I like to, and I know cosine and sine aren't very hard to type in, so you literally could go to your home screen. There's my phone. And you could go to the home screen and hit Math 9. I'm going to go, got to move this up just a little bit. I want to go from 0 to pi over 4. Now notice they put the parentheses. So again, I could type in cosine of x minus sine of x, but I'll be honest, it has a lot more parentheses. So remember that cosine was in y2. So I want my calculator to say y2 minus y1. But I want to integrate with dx, so that's my first one, plus, I can hit Math 9 again, pi over 4, not e, typed in the wrong thing, pi over 4 to pi over 2. And this guy is sine minus cosine, so that was y1 minus y2, and again dx, And lo and behold, the calculator's going to think for a second, and it is going to pop out the answer for you. And all you have to have is on a calculator portion is what I have right there. You can go to 3 decimal places and you have it. So let's look at number 4. So this again is a calculator one, and these graphs, you're like, oh, I'm not even going to look at those. I'm not going to try to graph those on my own. So let's get those in my calculator. So I am just, again, I'm going to denote which one I put where. So I'm going to make that one Y1 and this one Y2, so I kind of have it straight in my mind. And what do I have? Let's see, it's kind of hard. You never know where to put this calculator. I know you have it on your paper, so you can look at your paper there. And this is a great example of why I would thicken one of them, because you might not know which is which. So let's put this in. I like to do the fraction. So I have x over the square root of x squared plus 1. So I have that in y1. And then I have x to the 4th minus x minus 1. Now, I'm going to show you, so again, if you want to go over and thicken, you arrow over and you don't have a color, but you just kind of keep hitting enter on this. Wish I had the same calculator on this guy. Notice and the lines are thicker than the other. You go to the thick one and hit OK, and then you have it, a little bit thicker. Now I'm gonna go to zoom 6, because that's like the, negative 10 to 10. I can make my calculator a little bigger if I need to. I can kind of see the graphs there. All right, I see that region. I'm just going to show you zoom 4. Kind of zooms in real close to, a little bit closer to the origin. So I'm just going to zoom in. Again, your calculator is just a tool. There's not a perfect window, but I'm just going to make it a little bit bigger. So on my piece of paper, I'm just drawing it, not that you have to draw a picture to get credit, but I want you to see this. If you look back at these notes, you kind of have a weird graph there. I don't know if it really looks like that, but and then you have one that kind of comes up. Good enough. I don't know if that's perfect, but hey. But you have the bounded region. You certainly see that the bounded region is this weird shape here. Now, if this is calculator, friends, please listen to what I am saying right now. Holy cow. Okay, so here's what I want. You don't want to find these intersections by hand. I still am going to figure out whether I want to do dx or dy. Do I have the same top curve and bottom curve? Yes. So I'm going to do my area. It is going to be in dx. That is important for me to figure out, because that means the intersection points, I don't really care about the y values. I just care about the x values. So I'm going to do second calc intersect, and I'm going to go to this intersection point. Now, this is very, very important. On my paper, I can write it to 3 decimal places. Okay, I guess that should be 6, shouldn't it? Okay, this pen is not oriented very well. So negative 0.496. But it is very important that even though I write it to 3 decimal places, when I'm doing Math 9, I cannot do it just to 3 decimal places. I have to use all of it. So here's what I want you to do. When you do intersect, okay, that is stored into X. Go to your home screen and type X store into A. I usually do my bottom bound in A, and my top bound in B. So now that value is stored into A. I'm going to go again to intersect to get the top bound because I need to figure out what this top bound is. Again, on my paper, I can write 1.33. I don't have to write the 0, but you can if you want to just get in the habit of doing 3 decimal places. And again, I'm going to store that even though that's a rounded value. So I'm going to go to my home screen and do X because now that value is stored into X, and I'm going to store that into B. So now I have them there. Now, after that, it's pretty easy because I know which one is on top and bottom. If you have your thick and thin or whatever, or your colors, if you have that, you know which one is on top. This guy is on top and this guy is on bottom. So I can do 2 things. I'm going to move this dx over a little bit. If I do top minus bottom, then I'm going to have x over x squared plus 1 minus. You can either distribute the minus yourself. I tend to do that because I forget to do parentheses. So I like to just change the signs of everything. So notice it would look like this. And that would be my equation. Here's the other thing I want you to be very clear of. If these guys were named on my paper, because a lot of times on AP, instead of putting y equals, they say f of x equals, okay, this, and they say g of x equals this. And I certainly could write this on my paper if you want to. And if they name them with different names, if they say y equals, you don't know which one is which. But if they name them with names, y'all, this is what I would do on my paper. I would get my bounds, because I have to write my bounds, use the names of the functions. So I would say, I would write on my paper f of x minus g of x. Don't copy the whole equation. Use the names. You're less likely to make a mistake, and it's just much easier. It's less writing. So when I go to get this actual answer, I'm going to hit Math 9. I'm going to go A to B, and I remember in this case, I did y1. I know where I have them stored, y1 minus y2 dx. And it's using all of the values, and I'm not rounding my final answer, not rounding until my final answer, and that is going to be the area. So that's very important skills on the calculator, how to store those values and write those down. Some people even say, you know, when they get those intersections, they say A is negative 0.496 and B is 1.330. So when they write this, they write A to B. You can do that if you have established what A and B are, especially if you're on the AP test where you tend to use the same bounds. That might be nice so you're not copying those decimal places over and over again. You certainly can do that. So there's just certain skills that help you be faster and use the calculator, etc. Okay, last one. Last one. I'm going to get this calculator out of the way. Find the area of the region bounded by. Oh my gosh, what the heck does that look like? Well, I'm actually going to let's see, I'm going to kind of do this one partly. It says calculator. So the trouble is you're like, well, in a sense, I could do this one without a calculator, because if I used a calculator, I still would have to figure out what y equals, like I'd have to solve for y. So let's think about that. So I'm going to do the integrating on the calculator just so I don't have to do it by hand. But there's a lot of skills that you should be able to do without a calculator. So first of all, let's get the graph. If I solved this guy for y, it would be y squared is equal to 3 minus x. So y would be plus and minus the square root of 3 minus x. So what that looks like, and again, if you want to use a calculator to see what that is, if you don't know, that's fine. It's going to be one that's going like this. Okay. And then x minus 1, we all know what that looks like, I do believe. That's going to look like that. So there you go. Okay. Now here is the point I want to bring out with that one. Do you see your bounded region? Your bounded region is this region in here. Now, here's the issue. In reality, with area, you can choose to do dx or dy for every problem. You can choose. I could do every area problem. I can do dx or dy and get the answer. If I was doing dx, would this problem, the issue is if I had to do dx, do you see that I would have to do 2 integrals? Because what's on the top and the bottom changes right after this point right there. So I'd have to do 2 integrals. Now it's going to be very hard for me to erase and not just totally kill my picture, but do you see if I decided and said, you know what, instead of doing vertical lines, let me do horizontal lines to fill that area. Could I do horizontal lines and fill the area? Yeah. Now, why would I choose to do that? Because ask yourself, is the right and the left of all those horizontal lines the same? Yeah, you have the same curve on the right and you have the same curve on the left. So you might choose to say, you know what, I want to do this with dy. I want to get the area in terms of, I'm going to do dy. Now notice what we have on the first sheet when we put dy. Instead of doing top minus bottom, I'm going to do right minus left. But what's very important is that these are y values. Okay, they're the y values of your bounded region. So let's look here. I need to figure out the low y value and the high y value to get my bounds. Now again, I know I'm doing this kind of without a calculator because I don't know what part it's going to be on. So do you see, and here's the other thing. Remember what I said? If you're doing it in terms of dy, that means your equations have to be solved for x. So you have to do a step where you go, well, this guy would be y plus 1, and this guy would be 3 minus y squared. So if I want to define the y values of those intersection points, well, I would just set those two things equal. If they're both equal to x, I could do that by hand. I could move, I'm actually move, think about me moving to the right so my y squared is positive. So I would have y squared minus this. I would factor y plus 2 and y minus 1. So I get negative 2 and 1, which makes sense for my picture, doesn't it? This y value, low y value, is negative 2, and this y value is 1. My bounds are always low to high, so negative 2 to 1. Now, as far as finishing the integrand, what am I going to do? Right minus left. Which one of those curves was on the right? It was this one. So 3 minus y squared, and then I'm going to do minus this. And like I said, you can either put parentheses. I like to go ahead and distribute. And then I would go from there. Obviously, this is where I said, okay, I'll be lazy and actually use the calculator. I'm not saying you couldn't type that in, or couldn't do that integration by hand. You could, if you had to. But I'll use the calculator since it said negative 2 to 1. And I do want to make this point. Even though it says y's, I don't use the variable y in the calculator because I don't want to have to hit alpha y every time. So even though it says y's, I type in x's just because it's faster to type in, minus x minus 1. Again, I could have combined that to be 2, I know, but I'm just being a little lazy here. And I hit enter and I get 4.5, and so my area is 4.5. So yes, when you're typing in and you're doing dy, if you're using the calculator, I just go ahead, I have it on my paper as y's, but in the calculator I type in x's. So that is how you do area between curves. It's either top minus bottom if they're vertical lines and you're doing dx, or right minus left if you're doing dy's. All right, peace out.